In today's video, we are going to be graphing a system of inequalities. So that's your learning target, is to graph constraints using systems of inequalities. Again, a system is two or more equations. So in chapter 6, you learned that the solution to a system of equations is a point that makes both equations true. Remember, we worked with systems. That was involving the elimination method, equal values method, and substitution. And where our solution was graphically was where they intersected. But what about the solution of a system of inequalities? How can you represent these solutions on a graph? How many solutions can a system of inequalities have? So that's what we're going to be looking at. Now, here's the really exciting part. It is the same exact process of graphing just one inequality, except your solutions are in the double shaded area. So let's get right into it. And let's go ahead and graph these two lines. And so I'm going to start with this inequality. It looks like I'm starting at 5. My slope is -1, so rise -1, run 1. Looks like it would be a lot of little points. Okay, what's the next process? Is it solid or dashed? Because this inequality has a solid line, I know it's going to be a solid graph. I'm trying my best here with my tablet. And is it going to be shaded above or below? Well, because it's less than, I'm going to go to my y-intercept and shade everywhere below as best as I can. Okay, so I took care of that one. Now I'm going to look at this inequality right here. So I'm going to start at -1. My slope is 2/3. And again, slope is rise over run, which is 2/3. So from here, I'm going to rise up to run 3. Rise up to run 3. I can also go -2, -3. Where am I here? Okay, so that's approximately my line. Is it dashed or solid? Since there's no solid line, it's going to be dashed. And now I need to shade because it says greater than. I'm going to go to my y-intercept and shade everywhere above the inequality. Okay, so do you see how I shaded everywhere above the inequality? So I graphed my two inequalities, my system of inequalities. Now, where is the double shaded area? Do you see how it's just this region right here? That is where your solutions are. Your solutions are not, let's see, let me pick white. Your solutions are not here. They are not here. And they're definitely not here. Here is where your solutions are because it has to work for both inequalities. So in the last lesson, I said you guys can be testing your points. If I test -3, and I plug it into the first one, it will work. Let me see if I can do this quick. Is 0 less than or equal to, what was my x? Oh, no. My y is -3. Less than or equal to 0 plus 5. Is -3 less than or equal to 5? Yes. But if I plug it into my second equation, the answer, what is that? 10/3 minus 1 is no. And so that's how I know this is not a solution to the system of inequalities. So if you're going to test your points, you have to plug it into both inequalities, and they both have to be true. Okay, if you want to make sure and test your points. But that is how you graph a system of linear inequalities. The same exact way as graphing one, except your solution this time your solutions are going to be in the double shaded region. Let's try again. Y is less than x plus 2, y is less than or equal to 10 minus 3/4 x. Let's go ahead and start maybe with this one. All right, I'm going to use, I can still use yellow. Hopefully we can see that. And so I'm going to start at 2. And my slope, my coefficient to x is just 1. So instead of going up by 1s, I'm going to go up by 2s right here. Down 2 over 2. Okay, and I'm going to think about, is it a dashed or a solid line? Since there's no solid line, I'm going to have a dashed line. And where am I going to shade, above or below? Well, since it's less than, I'm going to go to my y-intercept and shade everywhere that it is less than. Oops, that's a little not accurate. So let's go ahead and start with the second inequality. I'm sorry if it looks a little different. I had to pause my recording, but let's move on. And so now let's work on this inequality. It looks not, well, it's not in slope intercept form technically because the constant is before the fraction. And so if you want to rewrite this just so it looks a little bit better, that's negative 3/4 x plus 10. Now it's in a form that I recognize better. I don't have to worry. And so I start at 10. Oh, I'm way up here. And my slope is negative 3/4. So I'm going to rise negative 3 and run 4. 1, 2, 3, 1, 2, 3, 4. And then it looks like, okay, so is it going to be dashed or a solid line? Well, a solid line in my inequality means it is going to be a solid line as best as I can. Again, use a ruler so you don't do that like I did. And now where am I going to shade? Am I going to shade above or below? Because it's less than, I'm going to go to my y-intercept and shade everywhere. Oops, do better than me. Less than that y-intercept. I'm just going to go a little crazy over here. Okay, and so I graphed my system of inequalities. Where are my solutions? The solutions are in the double shaded area. And so my solutions look to be in this region right here, where it's double shaded. And so if I ask you, is 0, 3 a solution to the system of inequalities? It is not, because it's not in the double shaded region. Is, I don't know, 6, 3, is that a solution to the system of inequalities? Well, if I look at 6, 3, it's in the double shaded region, so it is a solution. If I pick the point, -4, -2, if I go to, let's not do -2, let's do -1. If I go to -4, -1, it is not a solution to the system of inequalities. It's a solution to this green inequality, but not to the system of inequalities. Okay, let's go ahead and try another example. Y is less than 5/2 x plus 3. I'm going to start at 3. My slope is 5/2, so I'm going to rise 1, 2, 3, 4, 5, and run 2. I can also rise -5 and run -2. 1, 2, 3, 4, 5, 1, 2. Solid or dashed line. Both of them are going to be dashed lines. Boom, boom. And because it's less than, I'm going to shade less than the y-intercept at 3, which is all of these values. Moving on to the next one, let's do pink. So this one starts at -1. My slope is negative a third, so I'm going to rise -1, run 3, -1, run 3. I can also rise +1, run -3, rise +1, run -3. And again, it's a dashed line since the inequality is greater than, not greater than or equal to. And it looks like I'm shading greater than my y-intercept. So I'm going to go to my y-intercept and shade above. Everywhere above that line. So where are our solutions? And our solutions are in the double shaded area, which is right here. If I ask you, let's see, is 2, 0 a solution to the system of inequalities? It is. If you were to plug it in to both of the equations, they would work. Is, let's see, is 1, 9 a solution to the system of inequalities? It is up here and it is not. Okay, so that's how you can check where your solutions are. There are 4 regions to check from. And it looks like region 4 is the winner chicken dinner. This has no solution for either of these inequalities. The pink one, these are the solutions to this inequality only. This one, oh wait, I messed it up, huh? No. Let me redo that. This one, I think, was the purple one, the solution to that inequality. This region is the solution set to this inequality, but this region, region number 4, is the solution set to the system of inequalities. Okay, and again, you can always check your work, but this time, if you have a system of inequalities, you have to check a few points. You can't just check one side because now, as you saw in the previous slide, there's 4 regions, not just 2. Last equation, go ahead and pause it, try this on your own. I'm going to start with the first one. I start at 2. My slope is 4. 1, 2, 3, 4, 1. Rise up 4 over 1. I can rise -4 over 1. 4. Solid line means it is a solid dash. Let me try to do better. A little bit better. And let's see, I'm gonna shade with a different color so it's not too dark. Let's do, well, it's less than, so I'm gonna go to my y-intercept and shade everywhere less than that y-intercept of 2. Now let's move on to the next one. Let's choose this red color. And this is not in slope intercept form, so I'm going to change it. I'm going to subtract 6 from both sides, or 6x. And I'm going to divide both sides by 2. And I get y is greater than -3x minus 4. Notice how I didn't flip the sign because I did not divide by a negative. So now I start at -4. It looks like my slope is -3, so I can go -3 over +1, or I can rise 3 and run -1. 1, 2, 3, 1, 1, 2, 3, 1. And let me go ahead and see if I can do, oh, well, this is a solid or dashed line, and it is a dashed line, right? So I'm going to have to do a dashed line through these points. And am I shading above or below? Well, since it's greater than, I'm going to go to my y-intercept, which is right here, and shade everywhere above this line because it's greater than. So I've got some there, all the way here. Now, where is our solution set? Is it in region 1, 2, 3, 4? Oh my gosh, are there 5? 1. Oh, that's so silly. That is not a region. So 1, 2, 3, or 4, and the solution set is in region 4. All of this is the solution to the system of inequalities. That is it. I hope this was helpful.